So let's get right to it. We're writing chemical names given the formulas. This is a cation and an anion. These are the ones we love because they're very straightforward. Just write the name of the cation, the metal in this case, and then change the name of the anion to end in ID, or the second element to end in IDE. That's it. That was it. All right, let's keep going. This is two nonmetals, so we're going to use the prefixes. When there's a 1, we don't write the word the prefix mono. We'll just write the full name of the first element. The first element is usually the less electronegative element. You don't have to worry about it because it's just going to be in that order in the formula on our test. Hexa is 6. So this is you got to use those prefixes, hexa, and then fluoride. All right, so all these elements are going to end in IDE. Cobalt is a here we go, transition metal. So cobalt can have multiple charges because it's one of those transition metals that are not silver, zinc, or cadmium. We'll have to figure out what that charge is and also indicate it in Roman numerals. The second part, let's just write that down because that's not going to change. It's iodide, right? Iodine with the IDE ending. I want to rewrite that over here. So we have a 2 out here. Okay, we know iodine's anion charge is 1 negative, so that goes down there. All right, so what charge must cobalt be for this 2 to be over there? Well, that must have come from the cobalt, the charge on cobalt. So we can say that cobalt, this is cobalt 2. Iodide. 2 nonmetals, just write the name of the first element, this phosphorus. Okay, and we don't write the mono if it's 1. All right, now 5 is penta. F is fluorine, but let's change the ending to IDE, fluoride. That's simply a polyatomic ion, that's just chlorite. A cation and an anion, so just write the name of the cation, which is lithium, and then the anion, but let's change the ending to IDE, so it's selenide. It's another cation and anion, so just write the full name of the cation, sodium. This is a polyatomic ion, sulfite, so I'm just gonna, no need to change the ending. It's only when it's an element, so sulfite is the name of the polyatomic ion. All right, let's get some more. All right, aluminum chloride. So here's another metal, non-metal. Let's write the name of the metal. Aluminum, chloride. All right, change the ending to IDE. Again, we don't need to worry about these numbers here because that's just naturally the way they're going to combine based off the charges of their ions. Notice the charge there, that's just going to be the name of the polyatomic ion. All right, carbonate. Iron is a transition metal. Let's write the word down first, but we are going to have to figure out what that charge is because transition metals, many of them have multiple charges. So we know the second one is an element, so let's just get that out of the way. It's going to be nitride. All right, the elements we're going to change to an IDE ending. Right, I'm going to write that over here. So we know nitrogen forms a 3 negative anion, and so the question is what charge was the iron cation? Okay, well we know there are no subscripts, so those are just inferred to be 1. Okay, so we know this 3 had to come down here. So what is the subscript, or what was the subscript on the nitrogen in order for both of them to reduce to 1? Well, it had to be 3. All right, 3 and 3 reduces to 1 and 1, which is the reason we don't see any subscripts. All right, so that, in other words, that 3 must have come from the charge of the iron. So this is, we can say this is iron 3 in Roman numerals, nitride. Non-metal, let's use the prefixes. This is di. Let's write the full name of the first element, sulfur. All right, and di. Change this ending of the second element to IDE. All right, there's iron again, that's our transition metal. All right, let's write the name first, but we know there's going to be some kind of charge there. We need to figure that out. Okay, and this is the chlorate. Let's just get that out of the way. All right, so that's the chlorate polyatomic ion. All right, so I'm going to write that over here to the side. Chlorate has a 1 negative charge. Iron is what we're trying to figure out. Okay, so this do this in a slightly different color. This 1 is responsible for that subscript, and this 3 must have come from the iron. Okay, so if we reverse crisscross, we can say this is iron 3 chlorate. Cation, polyatomic anion. This is that's not a polyatomic ion, so we don't have to worry about any of these charges. Just these are like the ones we love. All right, just write the name of the cation, calcium. All right, in this case, you don't have to worry about the element. It's just a polyatomic ion, so that's oxalate. Nonmetal, nonmetal. Let's use the prefixes. Tetra is the prefix for 4, tetraphosphorus, and tri is the prefix for 3. All right, again, change the ending to IDE, so it's sulfide. Tetraphosphorus sulfide. Okay, metal, nonmetal. Name of the metal is calcium. Name of the nonmetal is sulfur, but let's change that ending to IDE, calcium sulfide. I think I give it too many problems. Oh, this one, be careful. This looks like the chlorite polyatomic ion, doesn't it? But it doesn't have a charge, so it is not a polyatomic ion. Let's just follow our rules for a nonmetal, nonmetal, right? This is we don't write mono for the first element if there's only one of them. So this is simply chlorine, the full name, and then di means 2, oxide. All right, so be careful. Now this one is a polyatomic ion because there's a charge indicated there. All right, so this is just sulfite. 2 nonmetals, let's use the prefixes, di, nitrogen, pent. It's a penta, right? But if the element starts with a vowel, like oxygen, you can drop that A, the last vowel of the prefix, so it's pentoxide. All right, again, IDE ending on all of these elements. What are we at? Back to blue. All right, nonmetal, nonmetal. All right, there's a prefix there. We need to use di for 2. Just write the full name. Chlorine. Dichlorine. Octa, drop the A because oxygen starts with another vowel, so it's oct oxide. All right, magnesium is a cation and hydroxide is a polyatomic anion, so let's just write the full name of the cation, magnesium. Okay, not a transition metal, so we don't have to worry about these charges. And just write the name of the anion, hydroxide. This one ends in IDE, but it's not an element, it's a polyatomic ion. Cation, anion, sodium, nitride. Here's a cation, that's not an element, so same rule though. Ammonium, just write the full name. All right, now that's the sulfite, polyatomic ion, so I'm just going to use that, and that's all there is to that. This one looks like sulfite, right? But the difference here is this is in a compound, so we know that's an anion, but this is all by itself, so this is a molecule. It's a molecular sulfur, 2 nonmetals. Just follow the rules for your molecular compounds. Full name of the first one, sulfur, is less electronegative, so that's written first, and then tri, use the prefixes, oxide. Let's get some more. Okay, gotta check in on my experiment again. Let's do a few more though. What color did we just use? All right, okay, zinc. That is a transition metal, but that's always going to have a 2 positive charge, so no need to worry about. Oh, no, what am I doing? All right, no need to worry about transition metals figuring out the charges on this. So just write the full name of the cation, zinc. And sulfur, we're going to change the ending to IDE. Ooh. All right, well, okay, so there's 2 parts to this, just like all of these are, right? So here's our metal, here's our cation, so let's just write the name of that, lithium. Okay, so that's right away we're good because it's not a transition metal. We just need to figure out what that second part is. Okay, so that's a sulfate with a proton, so we can call that hydrogen sulfate or bisulfate. Right, now it has 3 parts of the name, but that's just the name of this polyatomic ion. Wait a minute. Oh no, that is correct. That's the correct formula. thought there was an error, but it looks good. All right, carbon and sulfur. Carbon, let's use that prefix, disulfide, classic ionic compound. Potassium chloride, IDE. All right, metal, anion, cation, anion. All right, potassium. ClO minus is hypochlorite. All right, that's the fewest oxygen on these halogen polyatomic ions, so it's hypochlorite. All right, next one is cation and anion. All right, so let's write the full name. Oh, 3 potassiums in a row. Potassium, all right, that's permanganate. Non-metal, non-metal, we need to use the prefixes. If the first prefix is not a 1, we need to write it. So it's disulfur, deca, fluoride. Copper, transition metal with multiple charges. So let's write the full name of the metal first. We know the second is oxygen, so that's going to be oxide. All right, let's figure out what that charge is. All right, CuO. We know the charge on oxygen, anion, is 2 negative. And we're looking for the charge on the copper. Okay, when we cross this, we know that 2 goes over there. And now what number here on the bottom subscript of oxygen, all right, when reduced, will give us 1 and 1. All right, I'm saying 1 and 1 because there are no subscripts in CuO. All right, so hopefully you recognize that there needs to be a 2 subscript below oxygen. That came from the charge of the copper cation. So we can say this is copper 2 oxide. And once again, because copper can have multiple cations. Oh man, I feel like just cutting this list off right now. Calcium. How are we doing? Are we getting all these right? Most of them? If you have any questions, just ask. Calcium oxide. Let's get through this. Non-metal, non-metal. We don't need to write the mono, so let's just write phosphorus. What? Phosphorus. Huh. Okay, try. 3 is try. I feel like we did this one. All right, copper. Uh-oh, there it is again. Transition metal. Copper. Let's just write that down. And do you remember? Selenide, IDE. All right, change the element name to and then IDE. All right, what charge is copper in this one? Why don't you pause your video if you haven't been doing that? All right, so we know the formula is Cu2 Se. All right, so what's the subscript here? What must it be? All right, and because there's no subscript, that must be 1. So that means the charge on this copper was 1 positive. Okie dokie, that's just 1. We have to indicate that though, because copper could have a 2 positive charge too. Barium oxide. Okay, magnesium. I love magnesium and barium. These are not transition metals, right? So we're just going to write the word out or the name, magnesium. All right, so what is NO3? Is nitrate. That's all it is. All right, again, sodium. It's not a transition metal. It's just sodium. So don't worry about these subscripts. All right, and then PO4 is phosphate. Add hydrogen to it, so it's sodium, hydrogen, phosphate. Or you might call that biphosphate. All right, copper. Uh-oh, copper is a transition metal with multiple cations, so we got to figure out what that is, and we have to label that in Roman numerals. All right, but we know bromine's name is going to just change to bromide, so let's write that down and go over here. All right, so I'm just copying the formula given. All right, we know bromine is a halogen, so it has a 1 negative charge. All right, that 1 is the subscript down there that we don't write, because in chemistry we don't write 1s. Right, so what must the charge on copper be for this 2 to be there? So that 2 came from the charge on copper, so this is copper 2, bromide. All right, metal, non-metal, cation, anion. These are the best. All right, strontium and fluoride. Oops. IDE. Just change the name to end in IDE. Not doing bad. Okay, another. Let's see, what color did I just use? Here we go. All right, another cation, anion, seat. Oh, I thought I changed my color. There we go. Just write the name of the metal, cesium, and change the ending to IDE for the non-metal oxide. Okay, sodium, cation, anion. All right, sodium. All right, this is only one oxygen, so that's your hypoite, hypochlorite is the name of that polyatomic ion. All right, two nonmetals. First one, we don't need to write mono. Let's see if I spell this right. Iodine, hepta 7, fluoride. Change the ending to IDE. Tin, okay. New transition metal here with multiple possible cations. So we got to figure out the charge and indicate it using Roman numerals. All right, so we're going to determine that using the anion portion. So we know that's phosphate. Okay, let's rewrite that over here to the side. Just the way it's provided. Okay, so we know phosphate has a 3 negative charge. It's a polyatomic ion with a 3 negative charge, right? Well, that makes sense. That's why we see that 3 down there. So what could have caused this 2 to be outside the phosphate? Right? If you reverse crisscross, right, that must have been the charge on the tin. So this is tin to phosphate. Iron is another transition metal. I'm getting tired of these transition metals. Iron, I've got to figure out the charge, but the second element, we're going to change the oxide. Let's do that over here. All right, just rewrite the formula that's given. All right, we know oxygen's anion charge is what? Did you say 2 negative? Good job. That's where that 2 went. All right, so what charge was iron in order for that subscript next to oxygen to be 3? All right, you're getting that right? 3. 1, 2, 3. Roman numerals. Okay, please don't crash on me now. Di, let's use prefixes. Nitrogen. All right. Mono. Well, we'll drop that O because that would be 2 O's. It will be monooxide. We'll just call it monoxide. Metal, non-metal. Sodium oxide. Okay, chromium, transition metal, multiple charges. Let me change the color up. All right, let's write the name first because that's not going to change. But we do need to figure out the charge based off of the charge on nitrite, which is what that polyatomic ion is. All right, let's do that over here. I'm just going to copy that. Oh no, my experiments. All right, last one before I need to pause this video. Okay, so nitrite is a 1 negative charge. That 1 is going to crisscross down there. Let's reverse crisscross, and that chromium must have been a 3 positive cation. So that's going to be chromium 3. I'll be right back. You should never leave your experiments unattended. I got to do that one over again. And I'm running out of time. I got like 10 minutes before my next class starts rolling in here. So let me see if I can talk faster. 2 nonmetals, oxygen, and drop the mono on the first name because we don't write mono oxygen, and difluoride. Magnesium is the name of the metal. Nitride, change nitrogen to end in IDE. That's all it is. There's another one. Love these. Right? Sodium, just a cation name. and then the anion name with the IDE ending. That's all it is. There's another one, 3 in a row. Just write the name of the cation, and then the name of the anion to end in, if it's an element, end in IDE. All right, ammonium is the cation. Just write the name of the cation. And then oxalate, just write the name of the anion. Okay. 2 nonmetals, write the name. Phosphorus, use prefixes where you see numbers, try, and then the second part ends in IDE if it's an element. There's another one, cation and anion, potassium, write the name of the cation, potassium. All right, sulfate, no need to change the ending if it's a polyatomic ion, just write the name of that. Endless. Okay, let's do it. Barium, not a transition metal, so we're happy. Just barium. All right, that's nitrate. Just recognize that and name it, and we're good. All right, now this is an element, so we're going to have to change that to IDE. Change colors. Barium. Sulfide. Gotta write faster. Iron. All right, I should be getting frustrated. Yay! Iron has multiple charges, so we know sulfur is going to change its name to sulfide because it's an element. All right, let's do the work here. Sulfur has a 2 negative charge that goes down there. So what charge here would give it a 1-to-1 ratio when reduced? All right, this is iron 2, sulfide. Okay, aluminum, fluoride. Right, love these, and they're not transition metals. Just write the name of the cation and then the name of the anion and with an ID if it's an element. All right, just like this one. Just write lithium. Now this one's not an element, so just write the name of the cation instead, and so that's sulfite. Same thing here. That's not a transition metal, so just write aluminum. That's the name of the cation. Aluminum. Hydroxide. Okay. Let's see here. All right. Sodium. All right, so that's chlorate. 2 nonmetals. We need the prefixes di. The first one is going to get its full name, nitrogen. Di. The second one is going to have an IDE ending. Show me the end. There it is. All right. Iron, transition metal with multiple charges. Sulfide is what it's going to be because that's an element, sulfur. All right. Fe2S3. All right. We know sulfur has a 2 negative. Let me do that in a different color. When it's an anion, it's 2 negative. That's where that 2 comes from. What charge was iron? It must have been 3 positive if you reverse crisscross. There it is. All right, 2 nonmetals. Beautiful. Oh, forgot that. What did I forget? Prefix. Tetrabromide. All right, nitrogen, 2 nonmetals. There's only one there. There's no prefix. What am I saying? There is a prefix. It's monoxide. Let's just drop one of the O's and monoxide. Okay. Copper, transition metal with multiple charges. We got to figure out the charge. All right, NO2 is nitrate. I'm sorry, did I say nitrate? I meant nitrite. Okay, let's figure this out. Cu, parentheses, NO2, parentheses 2. We know the charge of nitrite and nitrate, this is nitrite, by the way, is 1 negative. So that's going to crisscross over there. Let's reverse crisscross. That tells us the copper was a 2 positive. version. Don't mess up. 2. Okay. Another copper. All right, phosphate. Oh, no, phosphite. Oh, phosphite. Okay, let's figure out the charge. Cu3, PO3. Okay, we know phosphite has a 3 negative charge. That's where that came from. Now this is, there's nothing out there, just a single one of those. So this must be 1 positive. What color? That's copper 1. 2 nonmetals. Sulfur gets its full name. The second one, hexa, is 6. Bromide, let's change the name to end in IDE. Okay. Lead, another transition metal with multiple charges. We got to figure that out, but we know it's going to end in oxide. All right, let's do that over here. Let me see these transition metal ones for later. Okay, we know oxygen has a this one's a okay. This one's fun. All right, we know oxygen has a 2 negative charge. That goes down here. All right, but it's a 1. There's no 2 there. So, all right, how do I explain this? All right, so let's make that a 2. Okay. What must have this one been? I'm trouble. All right, look, that was a 4. All right, that's an awful explanation. Let me try that again. So we know oxygen, when it turns into an anion, is a 2 negative. So that would have crisscrossed there, 2. Okay, but in the formula, it's not a 2, it's a 1. So it must have gotten reduced from 2 to 1. So if this is going to get reduced to 2 to 1, this must have been 4 to get reduced to 4 to 2, right? So the original charge on this lead is 4 positive. All right, so you might need to rewind that and play that over again, because let's see here, Roman numeral 4, because I got 2 more to go, and I got like 2 minutes. 2 nonmetals, carbon, tetra, chloride. Last one. Okay, why don't you try, well, you should be trying all these. Manganese, that's how you spell that. All right, now what chart is the transition metal with multiple charges? So I got to figure out one more of these. We know it's going to end in sulfide. All right, MnS2. All right, we know salt. Here's another fun one. All right, we know sulfur anion is a 2 negative. When that crisscrosses down there, that's a 2. Okay, but it got reduced to a 1. Because there's that subscript there's no subscript, so it means it's 1, but it was originally 2. So what must have this originally been? All right, this must have been 4 and got reduced down to 2. So this is manganese 4. Because you can work it out. Do do manganese 4 positive and sulfur 2 negative, and crisscross them, reduce them, you'll get this original formula. So you can check your work that way. All right, if you have any questions, let me know.